Hello. In this segment, we're going to talk about how memory operates internally at a very high level. If you'll recall our detailed architecture of the little man computer, we talked about the memory address register, the MAR, and the memory data register, the MDR, as being our ways that the CPU read and write memory. But what actually happens inside of main memory once we transfer something to or from the MAR? This is a model of what the MAR and the MDR do. It turns out that when you put an n-bit address into the memory address register, that bit pattern will activate one of 2 to the n lines through an address decoder. So, if we put in an 8-bit pattern into the memory address register, one of 256, that's 2 to the 8th power, address lines will be selected through the decoder. We then assert the chip select, which turns on that one single line, and so all of the other data, all the other memory is quiet while we see what comes out of that one single line. Then the read-write signal is asserted, a 1 for a read or a 0 for a write, determining whether or not we're writing to memory or reading from memory. The width of the MAR determines the number of addressable lines that we have. With an 8-bit machine, this would be 256 possible addresses. With a 32-bit machine, we'd have about 4 billion different addresses. The width of the memory data register then determines the word size. In this picture, we see 8 bits that are flowing into the MDR, but the MDR could also be 16 bits or 32 bits wide. This is where we get the idea of a 32-bit machine or a 64-bit machine. This is typically the width of the MDR. The word size then, times the number of addresses, gives you the total memory that you can address in bytes. In summary, the memory address register determines which line of memory we're going to access. The chip select signal is going to activate the memory, and then a 1 for read-write will read, a 0 will write. The MDR then either sends or receives data from memory based on the read-write signal.